Okay, example 3, and before I start, I'm going to write this in exponential notation. So I've got x squared plus y to the 1/2 is equal to x squared y cubed plus 5. Okay, before I start taking this derivative implicitly, I just want to summarize the kind of rules I'm going to need. So right here, I know how to take the derivative of x to the 1/2. It's 1/2 x to the minus 1/2. How do you take the derivative of y to the 1/2? 1/2 y to the minus 1/2 y prime. Because you've got an inside function and you need a chain rule. Taking this derivative, I'm going to need a product rule. And when I use that product rule, first function times the derivative of the second, I'm going to need to do it implicitly because y is a function of x. Okay, so here we go. Taking the derivative of both sides of this equation then, I get 2x plus the derivative of y to the 1/2, 1/2 y to the minus 1/2 times the derivative of the inside function, y prime, is equal to, using a product rule, the first function, x squared, times the derivative of the second, the derivative of y cubed, 3y squared, y prime, plus, product rule, the derivative of the first, 2x, times the second, y cubed, plus the derivative of a constant, of course, is 0. Okay, so let's get all of the y primes over on one side. So here's y primes, and everything else I'm going to move over to the other side. So I've got, how do I want to do this? I'll just do it like this. 1/2 y to the minus 1/2 y prime, subtract, and I'm going to put this in a little bit of logical order, 3x squared y prime is equal to 2xy cubed subtract 2x. Okay, so just follow the algebra. I left this here on this left side, on the right side of the equals, and I moved the 2x over, which is why it's negative. I left this one here on the left side of the equals, and I moved the x squared 3y squared y prime, which is why it turned negative. Yes? Okay, why does there need to be this y prime? Because we took the derivative implicitly. I'm taking the derivative of y to the 1/2. Or y is a function of x. This is the derivative of f at x to the power of 1/2. So the power rule would tell me that this derivative is 1/2 f at x to the minus 1/2 times the derivative of the inside function f prime at x. And then I'm using y's instead of f at x's. So this is giving me 1/2 y to the minus 1/2 times y prime. Okay, are we good? Okay, so there's the understanding piece. The rest of this is algebra. We're going to factor out the y prime. And I'm left with 1/2 y to the minus 1/2 subtract 3x squared y squared is equal to 2x y cubed minus 2x. And solving for y prime, I get y prime is equal to, let's factor this, 2x bracket y cubed minus 1 divided by 1 over, well, I won't do this all at once. I was going to say 1 over 2 root y, but let's just make it easy to follow. 1/2 y to the minus 1/2 subtract 3x squared y squared. Okay, you shouldn't leave fractions and negatives in your exponent. I'm going to change this to radical so it's easy for you to see how to fix this. Of course, you all see you could factor that, right? In my denominator, 1/2 y to the minus 1/2 is 1 over 2 root y. So pay attention here, you've got two terms. You can't just take and flip that. How do I get rid of this fraction in the denominator? I'm going to do the same thing to the numerator and the denominator. Multiply by 2 root y. So I'm going to get 4x root y, y cubed minus 1, over, distributing this to both terms, 1 subtract 6. X squared, y squared, root y. So there's our final answer. Okay, I'm going to